Remember that throughput measures the number of tasks that can be performed per unit time. Here we have a web server that can perfectly handle one request at a time. When it receives a burst of traffic, it starts slowing down. The website server is single-threaded, so it can only respond to one request at a time. We can provide the server with a thread pool. A thread pool contains idle threads that are ready to fire up as soon as work is given to them. Now the application can respond to many requests in parallel. You can start by downloading the course materials from the GitHub link that I'm going to leave you inside of the video's description. Once you download the zip file, extract the contents of your zip and load the increasing throughput starter project onto your preferred IDE, and let's begin. Alright, we can start by opening up the starter code, and if you're from my Java course, you might be wondering, whoa, Rayan, what's all this? Well, in my Spring Boot course, which I know you'll sign up for because it is an awesome class, I'm going to teach you everything you need to know about clients and servers, but in the interest of keeping the focus on multi-threading, let's keep it very simple. This code creates a server, a web server that listens for requests on port 8080/factorial. And upon receiving a request, the application sleeps for 5 milliseconds and then returns hello world to the client. So you can feel free to test this out by running the app and then going over to your favorite browser and making a request to our server, which simply returns hello world. Okay. And from the course resources, you should also find a client tester starter project. Please launch it on another window of your preferred IDE. And we're going to open up the code. Don't mind this code. All this does is it makes 100 requests to our server, which is serving them on port 8080/factorial. So it's going to make all of these requests to our server, and then it's going to measure the throughput. How many requests was the web server able to handle per second? If I were to test the throughput now, it seems that our server can handle 140 requests per second. Obviously, your performance may vary because we have different machines, but anyways, 140 requests per second, that's not bad, but we can do a lot better. Right now, my server is executing 100 requests on a single thread. So what we can do is set the server's executor to handle all of these requests on a fixed thread pool. So we're going to set the executor equal to executors.new fixed thread pool. Every request that comes, we're going to execute them in a thread pool of 8 threads. Why 8? Well, actually that number might be different for you. What I'm going to do is say int number of threads is equal to runtime.getRuntime.available processors. This returns the number of available processors, the number of available cores in my CPU. For me, that's 8. For you, that might be different because we have different CPUs. So I'm going to go ahead and print it just to show you. And I'm going to set our server's thread pool to have as many threads as I have cores in my CPU. So let me go ahead and print it for you just to show you. So I've got 8 cores in my machine, which means I'm going to have 8 threads in my thread pool ready to fire up and handle all the requests that get sent to my server. So if I rerun the server, go back and measure the throughput, we get a much better throughput. My server was able to handle 520 requests per second when we added 8 threads. But that's not all. If we actually execute a second time, it's way faster this time around. Why is that? Because we're using a fixed thread pool, the very first request that was made to the server, it involved actually initializing these threads. But then after this initial setup, the threads sit idle and they're ready to fire up as soon as more work is given to them. That's why the throughput is much higher the second and third time around. But anyways, that's the beauty of a thread pool. The threads are always on standby, and the server keeps reusing them quickly to handle new tasks. If we were to constantly create and destroy threads every time a request is made, that would be very expensive. but a thread pool reuses a set of existing threads, which reduces the overhead associated with creating new threads for each request that is made. Alright, in the first video of this series, we talked about a phenomenon called thrashing, whereby the CPU spends more time switching between threads as opposed to actually executing them. Now, CPU cores can only process one thread at a time, and they can get overwhelmed by switching between too many threads. So one might assume that if we increase the number of threads beyond the number of cores that I have available, then the server will become slower. Let's test this out. I'm going to rerun my server. Okay. We're going to ignore the first test, run it a second time around. Wrong. It's actually a lot faster. Remember when I told you that CPU cores can only process one thread at a time? This was until Intel introduced hyperthreading, whereby certain sections of the CPU core are duplicated. If each core can now execute more than one task, then my CPU should easily be able to handle double the number of tasks. That's why increasing the number of threads in our web server's thread pool beyond the number of cores significantly improved its performance. We went from like 600 requests per second to 952, almost 1,000. Hyperthreading can really improve throughput because it's very well suited for tasks that require much less CPU computation. This is a very light task. So what is the ideal number of threads? There is no magic formula. Most web servers already implement a thread pool with a dynamic number of threads, which are scaled based on the amount of workload that can be handled by the web server. For instance, if you decide to spin up a web server with the Spring Boot framework, the thread pool is already set up for you out of the box, so it's not something you typically need to worry about as a web developer. However, it's good to have a general understanding of how these things work. So to recap, if a website server is single-threaded, it can only respond to one request at a time. We can provide the server with a thread pool. A thread pool contains idle threads that are ready to fire up as soon as work is given to them, which allows your application to respond to many requests in parallel.